Welcome to the Deep Dive, your shortcut to getting informed on things that, well, really matter.
And today, we're doing a critical deep dive into something fundamental: sleep. We've got a whole stack of research here, and it's not just about sleep being, a pillar of health.
Right, we're moving past that metaphor.
Exactly. We're looking at it as the foundation, the bedrock upon which everything else, your physical health, mental clarity, everything actually rests.
That's the mission today. Not just the upside of good sleep, but the, frankly, catastrophic costs when we consistently miss out. And this isn't just a personal issue, is it?
No, not at all. It's genuinely a global crisis. The World Health Organization, they've flagged a sleep loss epidemic across major industrialized countries. Think the US, UK, Japan, South Korea.
Wow. An epidemic.
Yeah, and the numbers are pretty shocking. Get this. 2/3 of adults in these places consistently fail to get the recommended 8 hours of sleep a night.
2/3. That's the majority. It means chronic sleep debt is basically the norm now.
It seems to be.
So that brings us to the core question for this deep dive. What are the hard, proven consequences? Let's start with the body itself. What happens biologically when you routinely get, say, less than 6 or 7 hours?
Well, the damage is pretty immediate and widespread. Even just dipping below that 7-hour mark routinely, it really compromises your basic biological systems. Take the immune system.
Right.
Insufficient sleep essentially cripples it. We're talking about more than doubling your risk of developing cancer because your immune system just isn't effectively identifying and killing those malignant cells.
Doubling the risk. That's huge. And completely avoidable, theoretically. What about the brain? That gets a lot of focus, especially long-term risks like Alzheimer's.
It absolutely should. Lack of sleep is now seen by researchers as a key lifestyle factor, a really significant one, in increasing your risk for Alzheimer's disease down the line.
Okay, so long-term neurological risk is clear. But are there more immediate effects?
Oh, definitely. You don't need to wait decades. Metabolically, for instance, just moderate sleep reduction. We're talking maybe an hour or two less than you need for just 1 week.
1 week.
1 week. It can mess with your blood sugar processing so badly that clinically you could be classified as pre-diabetic.
That's incredibly fast. I mean, I know I feel groggy and unfocused without enough sleep, but internal damage that quickly.
It's profound.
And I guess the link between poor sleep and weight gain is something many people experience. How does that work physiologically?
Yeah, it's kind of a cruel double whammy. Lack of sleep ramps up ghrelin production. That's the hormone telling you you're hungry.
Okay.
And at the same time, it suppresses leptin, which is the hormone that signals fullness or satisfaction. So you feel hungrier and you feel less satisfied by the food you do eat.
And the sources mention something really frustrating, too, that if you try to diet while you're sleep deprived.
Yes, this is the real kicker. If you're dieting but not sleeping enough, most of the weight you lose isn't fat. It's lean body mass.
Muscle. So it completely undermines the whole point of dieting for fat loss.
Pretty much. It sets you up for failure, slows your metabolism. It's just counterproductive. But, the impacts go way beyond just our personal health. They spill out into public safety immediately.
You mean drowsy driving?
Exactly, the drowsy driving crisis. The statistics here are, they're sobering. In the U.S. alone, there's a death on the road every single hour linked to fatigue-related driving errors.
Every hour. That's horrifying.
And here's the comparison that often gets missed. Vehicle accidents caused by drowsy driving actually kill more people than those caused by alcohol and drugs combined.
More than alcohol and drugs combined. How? Is it just that more people drive tired?
Volume is part of it, sure. But the mechanism of the crash is fundamentally different and deadlier. A drunk driver, they're impaired, they react poorly, maybe too late.
Right.
But a drowsy driver experiencing a microsleep, even just for a second or two, they stop reacting entirely. There's no braking, no swerving, nothing. It's like an unguided missile.
Just total absence of control.
Total absence, which leads to much higher impact speeds and more devastating outcomes.
Okay, so when we feel that sleepiness creeping in during the day, what do most of us do?
Yeah.
We reach for coffee, right? Caffeine seems like the obvious fix.
It's the default, yeah. But it's really what the source calls the caffeine trap.
The caffeine trap?
Yeah. So caffeine is a stimulant. Its main job is to block adenosine receptors in your brain. Adenosine is that chemical that builds up throughout the day, creating sleep pressure.
So caffeine stops us feeling tired by blocking the tired chemical.
Exactly. But here's the trap. The adenosine doesn't go away. It keeps building up, accumulating behind that caffeine blockade, The sleep pressure's still mounting, you just can't feel it.
Like a dam holding back water.
Precisely. And when your liver eventually processes and gets rid of the caffeine, there's a specific enzyme that does that massive buildup of adenosine that's been waiting. It floods your receptors all at once.
Ah, the crash.
That's the caffeine crash. It's not just baseline tiredness hitting you, it's all the accumulated sleep debt hitting you like a ton of bricks. It's a sudden, powerful urge to sleep.
So it doesn't solve the underlying problem. It just delays and maybe worsens the eventual feeling.
It absolutely worsens it.
Mm.
And it doesn't just mask tiredness. What about its effect on actual cognitive performance, especially complex tasks?
Good question. What does it do?
Well, it seriously messes with anything requiring careful planning, spatial reasoning, fine motor control. There was this fascinating NASA study back in the 80s.
Oh, yeah.
They gave spiders various drugs, LSD, amphetamine, and caffeine, and watched them build webs.
Spiders on drugs. Okay.
Right. And the spiders given caffeine, their webs were just bizarrely disorganized, completely incapable of resembling a normal functional web, even compared to the ones on LSD or speed.
Wow. So caffeine made them worse web builders than LSD.
In terms of structural coherence, yes. It really highlighted how caffeine can disrupt the brain's ability to execute complex, planned sequences. It's not just masking fatigue, it's impairing higher function.
Okay, that's a really vivid illustration. Let's shift gears a bit. Instead of fighting sleep debt, let's understand how sleep is regulated normally. You mentioned two forces earlier. Process S, the adenosine sleep pressure, and process C, the circadian rhythm.
That's right. There are two distinct biological processes, though they usually work together. Process C, the circadian rhythm, that's your internal body clock. It runs roughly on a 24-hour cycle.
Governed by that specific part of the brain.
Yeah, the suprachiasmatic nucleus, or SCN.
Yeah.
Tiny cluster of cells, but it's the master timekeeper.
And it keeps perfect 24-hour time.
Well, not quite perfectly on its own. There was this really cool experiment done deep in Mammoth Cave, completely isolated from sunlight and all external time cues.
Right.
It showed the natural human internal cycle isn't exactly 24 hours. It's actually a bit longer, more like 26 to 28 hours for most people left to their own devices.
So our internal clock is naturally inaccurate.
Slightly, yeah. Think of your SCN like a wristwatch that runs a little slow or fast. Daylight is the crucial signal.
The reset button.
Exactly. Daylight acts like turning that little side dial on the watch each morning, resetting us precisely back to a 24-hour cycle. This internal timing system is also what dictates whether you're naturally a morning person, a lark, or an evening person, an owl. Your chronotype.
And this lark versus owl thing, it's not just preference, is it?
Not at all. The sources are really clear on this. Your owlness, or larkness, is strongly determined by your DNA. It's pretty much hardwired, not a conscious choice or a sign of laziness.
That's a crucial point because, as the research highlights, modern society, especially work schedules, seems massively biased against owls.
It really is. Think about the standard 9 to 5 or often earlier starts. That schedule heavily favors larks and essentially punishes owls. It forces them into an unnatural rhythm, making them chronically sleep deprived simply because of their biology.
And this isn't just inconvenient, it has health impacts.
Major ones. This forced misalignment, this sort of societal jet lag, it leads to significantly higher rates of depression, anxiety, diabetes, cancer, heart attacks, stroke. All sorts of serious health problems are more prevalent in owls struggling against an early bird world.
But if there's this genetic variation, evolution usually has a reason. Why would we have both larks and owls?
Great question. There's a really compelling evolutionary advantage proposed. Think back to our tribal ancestors.
Okay.
If larks went to bed around 9 p.m. and woke at 5 a.m., and owls went to bed maybe 1 a.m. and woke at 9 a.m., there's only a short window, maybe around 4 hours in the middle of the night, when everyone in the group is asleep.
So less vulnerable time for the whole group.
Exactly. Instead of an 8-hour vulnerability window if everyone slept at the same time, this chronotype diversity cuts that down to maybe 4 hours. That potentially increases the group's survival fitness by like 50%.
So the night owl wasn't lazy, they were the night watch.
Kind of, yeah. An essential part of the tribe's collective security system, biologically speaking.
That totally reframes it. Okay, let's pivot now from the sort of physical health and genetics to what sleep does for our brains while we're sleeping, particularly around memory and learning.
Right. Deep sleep, especially the NREM, or non-rapid eye movement stages, plays this incredible dual role in memory. It's like preparing the ground and then planting the seeds.
Okay, so how does it prepare us? before we even learn something new.
It basically clears out your short-term memory storage. This happens in the hippocampus, which has limited capacity, like a USB stick. During deep sleep, information, facts learned the previous day get transferred.
Transferred where?
Via these powerful electrical bursts called sleep spindles, the information moves from the hippocampus to the cortex, which is like your brain's vast hard drive for a long-term storage.
So sleep literally makes room for new information.
Precisely. It refreshes your ability to learn. Studies actually show people have about a 20% advantage in learning new things if they've had sleep, even just a nap beforehand, compared to those who haven't.
20% is significant. Okay, so that's preparation. What about after we learn something? Locking it in.
That's the second crucial function, consolidation. Deep NREM sleep is what cements those newly acquired memories, making them stable and permanent. The more high-quality deep sleep you get after learning, the better you'll retain that information the next day.
It's not just facts, though, right? What about skills? Like learning an instrument or a sport?
Absolutely. Sleep actually perfects motor skills, even without any more practice. There's that classic anecdote, maybe you've heard it, of the pianist practicing all day, struggling with a passage.
And then they nail it the next morning after sleeping on it.
Exactly. And it's not just anecdotal. Research backs this up. Participants learning a complex finger tapping sequence showed, get this, a 20% jump in speed and a 35% improvement in accuracy after a full night's sleep. No extra practice, just sleep.
Wow. Sleep is basically a performance-enhancing process for skills.
It really is.
Okay, thinking about development. We know teenage brains are still under construction. How does sleep fit into that crucial final phase of maturation?
Sleep, particularly deep NREM sleep, acts like the brain's master sculptor during adolescence. Earlier in life, REM sleep helps build connections like electrical fertilizer.
Right.
But in late childhood and the teen years, deep NREM takes over with a different job, pruning. It strategically cuts back redundant or inefficient neural connections, streamlining the brain for optimal adult function.
Pruning, like trimming a rose bush for better growth.
Exactly like that. And guess which part of the brain gets this pruning treatment last?
Let me guess. The part responsible for rational decisions and impulse control.
You got it. The frontal lobe, that's the brain's executive control center, handling reasoning, judgment, critical thinking. It's the last area to fully mature under the influence of this deep sleep pruning process.
Which kind of explains a lot about teenagers.
It really does. It sheds light on that rationality gap. It makes sense of that slightly cynical quote often attributed to the insurance industry.
Oh, the one about why 16-year-olds drive like they're missing part of their brain.
Yeah, because they are. Developmentally speaking, the frontal lobe isn't fully online yet, and sleep is essential to finishing that construction job.
It takes time and a lot of deep sleep. Okay, so we've covered personal health, public safety, cognitive function, development. What about the bottom line? The economic cost of this sleep loss epidemic.
Yeah, this isn't just about well-being. It's a massive drain on the economy. The numbers are staggering. In the U.S. alone, inadequate sleep is estimated to cost the economy something like $411 billion every year.
$400 billion. How? Where does that cost come from?
Mostly lost productivity, people being less efficient, less creative, making more mistakes at work, and crucially, from errors in high-stakes professions.
Like healthcare. We rely on doctors and residents making critical decisions, often when they're exhausted.
Exactly. And the data there is truly alarming. Consider medical residents after pulling one of those marathon 30-hour shifts without sleep. They make 36% more serious medical errors compared to when rested. And in the ICU, the intensive care unit, they make a shocking 460% more diagnostic mistakes.
460%. That's terrifying.
It is. And other research confirms that being awake for about 22 hours straight impairs your performance, your reaction time, your judgment, to the same level as being legally drunk.
So we have professionals in life or death fields routinely functioning at a level equivalent to intoxication.
That's what the data suggests. It really forces you to question the culture and safety protocols in many demanding fields.
Absolutely. Okay, so bringing this all together for you, the listener, we've laid out the case that sleep isn't optional, it's foundational. And crucially, you can get used to functioning on less sleep. But that just means you've adapted to a lower impaired baseline.
Right. And the tricky part is, when you are sleep deprived, your own perception of how impaired you are is unreliable. Your brain kind of resets what feels normal. So how can you tell if you're chronically underslept? There are a couple of simple practical questions you can ask yourself.
Okay, give us the self-check. How do we know if we're carrying sleep debt?
All right, first question. After you wake up in the morning, maybe on a weekend without an alarm, could you easily fall back asleep around 10 or 11 a.m.?
Mid-morning nap test.
Exactly. If the answer is yes, you're almost certainly carrying significant sleep debt. Your body is telling you it needs more.
Okay, what's the second question?
Second question. Can you function optimally, feel alert, focused, productive without needing caffeine before noon?
The pre-noon caffeine test.
Yep. If the answer is no, if you need that coffee or tea just to get going properly in the morning, chances are very high that you're using caffeine to self-medicate chronic sleep deprivation. You're masking the symptom, not addressing the root cause.
Those are really clear, practical indicators. Okay, so to wrap this up, we know sleep loss and mental health issues are tightly linked, almost a two-way street. And the sources mention REM sleep, which we barely touched on, being critical for emotional regulation, maybe even standing between sanity and psychosis based on deprivation studies.
REM deprivation can induce paranoia and irrationality.
Right. So that leads us to a final, maybe provocative thought for everyone listening. If we actually prioritize getting the full 8 hours, treating it as truly non-negotiable,
Yeah.
what specific, measurable, positive changes might we see in our most vital institutions? Think about healthcare, government decision-making, technological innovation. What could full sleep recovery unlock for society?